Okay, where were we just now? Okay, right. So one pathway, two pathway reaction. Okay, just now for one pathway reaction, we have reactant producing product directly. That means we don't have intermediates. Okay, we don't have the reaction will be producing product directly lah. Okay, alternative to one pathway reaction, okay, we have more than one pathway reaction. So for example, two pathway reaction. Okay, all right. So look at the energy profile diagram that we have here. So we're gonna start with reactant. Okay, the punya starting point will be the same, guys. Make sure that when you have to draw the energy profile diagram, the starting point will be the same. It's just that the EA sahaja berbeza. Okay, the EA is now lowered. Alright, for two pathway reaction, dia cara jenis the catalyst yang bertindak balas tu adalah cara dia adalah yes, dia reduce the EA. Dia reduce the EA, it's just that dia ada few steps. Okay, dia lalu reaction kecil. Okay, alright. So as you can see, it is reduced. Okay, the EA is now reduced. This is the average EA lah. So it is reduced. It's just that dia ada dua EA now. Okay, remember yang ni? So maksudnya dia ada dua reaction dekat situ. Okay, dia produce intermediate. So reactant produce intermediate, and then this intermediate will react to produce the final product. Okay, alright. So it depends on the reaction itself. It depends on the catalyst used in the reaction. But okay, the main purpose of having catalyst in the reaction is to reduce the what we call that, the activation energy. Okay, it's just that kita kena aware lah kalau dia kata having two pathway reaction, maksudnya dia ada reaction kecil dekat sini. So this first step, then we have second step. So that means we have two steps there. Okay, so this will be two pathway reaction lah. It can also be more than two pathway. We can also have three pathway. That means we will have three EA there. EA. This is also another EA, and then another EA. Three pathway reaction. Okay, alright. So this is how the catalyst behave lah, basically. Okay, done. Aduh, lagi dalam 8 minit saya cuba. Guys, do you have class after this? Right. Exactly after this, you ada class tak lepas ni?
No, madam. S14 tak ada.
S14 apa? S13, do you guys rasa tak ada kelas kot? Tadi tanya saya boleh tak straight 4 jam tu. Ada kelas ke lepas ni? S13?
Ya, madam.
Okay, mungkin dia delay kot Okay, tak ada Okay, saya mungkin akan terlajak sikit tapi I need time before kita punya kelas 1 hour sebab kudrat saya dia kena berehat sebentar sebelum we have our 1 hour lecture. Okay, at 5 to 6. Si baik esok cuti kalau tak saya tak buat kot kelas macam ni direct macam ni. Okay. 1.7, the last subtopic for topic 1, reaction mechanism. Okay, so these are the learning objective for this subtopic. Okay, make sure that you cover them all. Okay, alright, moving on. Most reaction involve multiple steps. Okay, sebenarnya reaction is not as direct as we think they are. Okay, dia sebenarnya it's a process kan. Dia ada proses dia sebenarnya. It's just that when we observe an equation, we tend to make conclusion that this reactant, when we add these two reactants, it will directly produce this final product. Not necessarily like that. Dia tak semestinya macam tu. Most of the time, it requires several steps. Several anak-anak proses tu. Okay, that multiple step and finally produce product. Okay, all right. So that step in order to produce from the beginning to the final product is what we call reaction mechanism. It's actually a process lah. Okay, proses. Dia contohnya macam you nak ambil contoh lah, you punya cita-cita nak jadi doktor kan. You want to become a doctor one day. Alright, so yang kita tahu, katakanlah kita start from your SPM, you dapat straight A's and then you jadi doktor. Kan, dia punya equation dia, okay, straight A's, doktor. Kan? Tapi along the way tu yang kita tak tahu, yang not many people know about this, is a process from SPM to your to become a doctor tu, you have to go through asasi, you kena belajar teruk, bukan belajar teruk, you kena belajar betul-betul so that you score well in your SPM, and then you get into asasi, and then you have to score a CGPA, a certain CGPA for you to be entitled to do your degree in medicine, okay, and then you have to 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 study for another 5 to 6 years, okay, for medicine again, and then you kena ada you punya clinical apa benda tu, and then baru jadi doktor kan. So those jatuh bangun you tu, those steps tu, okay, are important, okay. If not, you tak akan jadi doktor, okay. So that multiple steps tu contribute to produce who you are in the later days. Itulah maksudnya mechanism dia. Okay, that is what we call multiple step. Tapi at the end, kita just tahu reactant produce product. That is what we call general equation. The general equation. Okay, alright. So, ataupun what we call net overall reaction. The net overall reaction is a result of series of simple reaction. Dia adalah hasil total of those series of simple reaction. Macam you tadi lah, SPM, doktor. SPM, doktor. The net overall reaction. You dapat SPM bagus, you dapatlah jadi doktor kan. Macam tu contohnya. Okay, alright. So, each of these is called elementary reaction. Okay, these small steps is what we call elementary reaction. A small reaction to produce the final product. We total up everything. Okay, this is what we call elementary reaction. So the entire series of elementary reaction that leads to product formation is what we call the reaction mechanism. The entire series of elementary reaction is what we call the reaction mechanism. Okay, right. Okay, the reaction, okay, let's look at this example. The reaction between NO and O2 can occur in 2 steps. Okay, so we want to this is the overall reaction that we normally see. Okay, guys, this is the normal, the overall reaction, the general reaction that we usually see for NO reacting with O2 to produce NO2. Okay, alright. Sebenarnya, in order to produce this final equation, okay, the reaction need to undergo this step 1 and step 2. So these 2 steps is what we call elementary step, guys. This what we call small reaction. Okay, when we combine all this, it will produce the final equation. Okay, all right. And then one thing that you should know is that, okay, this reaction is conducted without catalyst. Okay, guys, without catalyst. Okay, all right. So you have to also know what is intermediate. Okay, what is intermediate? How do you identify intermediate in your reaction? Okay, so what we have here is N2O2 is produced in step 1 and consumed in step 2. So N2O2 is the intermediate. Characteristic of an intermediate is it will be first produced as product, then later on used as the reactant. See, dia diproduce dulu sebagai product, and then later on will be used as a reactant to produce the product in the following step. And that is one, okay, that is one. Diproduce dulu sebagai product and will be used as a reactant. Satu. Kedua, it can be cancelled out, guys. because intermediate will not be presented in atau will not be appeared in the overall reaction. Nampak? Ada ke N2O2 dalam this reaction? No, we don't have it in the overall reaction. Okay, so those two are the characteristic of intermediate. Okay, make sure that you are able to differentiate. Later we have catalyst. So what is the characteristic of catalyst? How do you differentiate intermediate and also catalyst? Okay, so make sure you tahu apa beza dia. Okay, alright, moving on. This is an example lah. Dia suruh you identify intermediate and the elementary steps. So these two are the elementary steps. Okay. Another example, this decomposition of H2O2 occur in two steps. Okay, occur in two steps. Maksudnya dia ada dua step in order to produce this overall reaction, this final equation. And this reaction, okay, has catalyst. Okay, we use catalyst in this reaction with the presence of catalyst. Okay, so the question asks you to identify the intermediate and catalyst in the reaction mechanism above. Okay, alright. So maybe we can go for intermediate first. Sebab kita just now we had determined the intermediate and we also have identified the characteristic of intermediate. Okay, so it can be cancelled out. But first, okay, it should be present as it should appear as product first for the first step, and then following step it will appear as the reactant. Okay, so kita kena check dekat sini lah, kat bahagian produk dulu. Jangan tengok dekat reactant sebab dia kata produk dulu dan jadi reactant. Okay, so which one can be cancelled out guys? This one. Bukan H2O. OI minus. Betul tak? OI minus as a product and then we have it as a reactant. Okay, so this one can be cancelled out. So OI minus is the intermediate. Okay, how about the catalyst? Okay, alright. Catalyst, remember the definition of catalyst? Catalyst is added at the beginning of the reaction together with the reactant. And then at the end of the reaction, it will still be present. That means it will not be used up. Okay, it will not be used up in the reaction. Maksudnya dia ada bersama dengan reactant and then dia ada di akhir reaction dekat nombor 2. Reaction nombor 2 Alright, siapakah yang berkemungkinan berperangai sebegitu rupa? Siapa? Guys.
I minus.
Okay. Right. So it's I minus, and it can be cancelled out also because catalyst and intermediate will not be appeared in the final equation. So cancellation sama dia punya karakteristik intermediate dengan catalyst. It's just that how they are present in the first place. Okay, so I minus will be the catalyst. Okay, so these are the description on how to select ataupun to choose the intermediate ataupun the catalyst lah. You can go through it later. Okay, moving on. Okay, saya nak sampai dekat sini. Saya sampai dekat sini je. Sampai dekat sini saja. Okay, alright, nak samakan dengan kelas tadi. Alright, okay. Okay, alright, so we are done with intermediate and also catalyst, guys. Okay, alright. The rate law of an elementary reaction can be written from its chemical equation, and this rule only applies to elementary reaction. Okay, the elementary reaction is the small steps just now, small reaction, okay, before we can finally produce the overall equation in combine. Okay, alright, so remember last time saya pernah cakap every reaction has its own rate law. Mesti ada rate law. Every reaction has its own rate law. So this small step or elementary reaction by right should have their own rate law. Ada 3 step, ada 3 reaction. So, mesti ada 3 rate law with respect to each reaction. Okay, alright. The good thing about this elementary reaction is that we can simply write the rate law of this elementary reaction based on the chemical equation. Based on the chemical equation. That's the good thing. Maksudnya boleh based on the coefficient. Dia sebenarnya bukan based on coefficient, it's based on molecularity lah. Later, what is molecularity kita akan tengok. Okay, tapi molecularity is also correlate ataupun tally with the coefficient. Maksudnya boleh straight away the order tu. Last time kan order dia kita kena determine through experiment. Remember? Yang kita ada table and what not tu kan. You have to determine the order from the data given to you. But this one, the order can be taken directly from the chemical equation. Okay? So tak payahlah susah-susah nak cari guna direct initial rate method. Okay guys, this is only applicable to elementary reaction. If you are looking for the order for the general equation for this one lah, for example kan, if you are looking for this, of course you kena from experiment. But if you are looking for the rate law for this one, you can get it from the coefficient of the reactant. You dapat straight away. Because these are for elementary step. For overall, no, you have to go through experiment. Okay, you have to go through experiment. Okay, all right. So the observed rate law, however, okay, you have to make sure that the overall rate law, the overall equation, the overall equation pun ada dia punya rate law sendiri okay, the overall rate law yang kita determine from the data, from the experiment, data of experiment. The overall rate law derived from the mechanism. Okay, must agree with the observed rate law for the overall reaction. Sebenarnya, okay, kita kan ada small reaction tu, and finally we can have the overall equation. Okay, we can have the overall equation. So we can predict the overall equation punya rate law sebenarnya from this elementary reaction. Sebenarnya, okay, but we are not going to cover into that sebab we have discard. Okay, kita dah discard dulu, we have that in our syllabus, but now no longer, we don't have that. We don't have that part in our syllabus anymore. Okay, kita dah keluarkan. Okay, but what I want to see is that we must make sure that the one that predicted, the rate law predicted, the overall rate law predicted from the from the elementary reaction, dia mesti tally, okay, dia mesti agree with the observed rate law for the overall reaction. Okay, the overall rate law derived from the mechanism, sebenarnya kita boleh, we have that kemudahan untuk predict from the mechanism. But dia mesti agree dengan the observed rate law. Observed rate law ni is the one that we get from experiment, guys. Dia mesti agree. Okay, tapi like I said, kita dah tak, kita tak belajar this one in detail. Kita belajar very surface. Later kita akan tengok, okay? Kita akan tengok. Very surface, kita kena make sure that these two should be tally. Kalau tak tally, that means kita akan disregard this one. Kita hanya ambil from the experiment. Okay, right. The order of an elementary reaction is the same as the molecularity of that reaction. So depends on the molecularity, which I mentioned to you just now, also correlate well with the coefficient. Okay. So what is molecularity? Molecularity is the number of species that must collide to produce the reaction in an elementary reaction. Molecularity, molecule. Okay, molecularity means the number of species that must collide to produce the reaction in an elementary reaction. Berapa banyak molekul yang involved during the collision. So that is what molecularity means. We have unimolecular, we have bimolecular, and also thermomolecular. Okay, unimolecular. Uni means satu. Okay, satu. Contohnya elementary reaction yang kita ada lah to represent this unimolecular. We have A producing product. So reactant involved is only one reactant involved. After a while, dia akan change to product kan. So we only have one reactant involved. So how do we write the rate law of this elementary reaction? Kalau ada jenis yang macam ni, we can simply write rate is equal to Ka kuasa 1. Dah siap rate law untuk this elementary reaction. Okay? How about bimolecular? Bi stand for 2 kan? 2. Bimolecular means we have 2 species of reactant reacting ataupun colliding. Okay, alright. So possibility dia, option number 1 is when A react dengan A collide with A. That means we have 2A here. Okay, nak cerita yang dia involve dua particles colliding. So how can we write the rate law, guys? Rate is equal to K A kuasa 2. Sebab we have 2A kan? So that's why, itulah maksud saya bila kita boleh ambil from the coefficient. Another example would be, it's still bimolecular, it's just that now the A react dengan B. Tapi still 2 kan? Dia ada 2 dekat situ. Okay? Dia ada 2 particles reacting. So how do we write the rate law, guys? So rate is equal to Ka to the power of 1, B to the power of 1. So in total, 1 plus 1 will be bimolecular. Okay? Thermolecular. Tertiary, guys. Tertiary. That means we have 3 particles involved in the reaction, in the collision. So what the first possibility will be A. That means we have 3A there. How do we write the rate law? Rate is equal to Ka to the power of 3. So the order will be 3. Another option will be A, 2 A's, 1 B. Okay, that means the rate law for this type of thermomolecular reaction can be written as this rate times K times rate is equal to K times A raised to a power of 2 times B raised to a power of 1. So 2 plus 1 will be 3. Another example would be A plus B plus C. Okay, so you have 1, 1, 1. Still 3. Okay, so we can simply write the rate law based on the molecularity of the reaction. Okay, however, these thermomolecular reaction are extremely rare. Okay, because kenapa rare? You imagine, you kena imagine collision tu untuk produce product tu, dia kena berlanggar, tiga-tiga tu kena berlanggar at once, serentak. And the orientation must be correct and also the energy should be sufficient. So that's why rare. Okay, untuk dia datang bertiga serentak orientation yang betul. So imagine kalau you ada more reactant, so dia tidak semudah just by tulis equation. Dia logik ke tak logik sebenarnya in real life. Can the experiment be conducted? Okay, alright, boleh. Tapi itulah rare. Okay, last one guys. Okay, rate determining step. Okay, so what is rate determining step? Rate determining means penentu rate. Okay, step yang menentukan the rate of the whole experiment, of the whole reaction. Okay, alright. Remember, just now, in order to produce product, we have to go through several steps, multiple steps, and small reaction that we call elementary reaction. Okay, of all these reaction, small step reaction, small reaction ni, of all of them, dia kan ada its own rate law, dia ada its own rate kan, dia ada dia punya, masing-masing pun ada masing-masing punya EA and what not. Okay, complete, lengkap. Okay, of all these steps, for example, kata ada 3 steps. Of all the 3 steps, there must be one step that usually the rate is lower than the other. Mesti akan ada macam tu. Okay, right. Okay, point number 1. In any multi-step mechanism, okay, one step is usually much slower than the others. Okay, kalau you main lari tukar-tukar baton kan, lari tukar-tukar baton kan. Dalam ramai-ramai semua yang power-power tu, kalau compare betul-betul empat-empat tu, dia akan ada seorang yang kurang power sikit than the other. Okay? So yang kurang power ni, dia penentu. Dia penentu whether the whole group ni, dia boleh menang ke tak. Kalau dia slow, kalau because of her, the slowest one, okay, and then the whole group, the rate of the apa nama tu, the rate of the relay tu akan jadi slow because of her. Okay, itu maksudnya dia sebenarnya dia slow tapi dia penentu the whole rate of the reaction. Dia penentu kemenangan group 4 orang yang berlari tu. Contohnya you dalam group lah, tiba-tiba siapa yang terasa dia lah, siapa makan cili dia terasa pedas Dalam satu group tu, semua TikTok ada 5 orang kan. Tapi dalam ramai-ramai 5 orang ni ada satu yang kalau kena buat kerja dia yang paling slow. Kalau suruh submit, dia lambat submit. Kalau suruh respon, dia yang paling lambat. Okay, bila at the end of the day kena submit on time, dia tak do his ataupun her part. So you punya assignment ke whatsoever, semua drag because of her ataupun because of him. So dia penentu. So that is what we call rate determining step. Banyak sangat contoh lah dalam adik-beradik kita pun kan. Dalam ramai-ramai tu mesti akan ada seorang yang take his ataupun her own sweet time nak bersiap. Orang nak cepat, dia suka-suka lambat. Okay, masing-masing. Macam tak ada hal, tak ada kena-mengena dengan orang lain. Bukan jentik dahi dia baru tahu Okay, dia suka hati dia chill kepala otak. Okay, so itu melibatkan orang lain, menyusahkan orang lain. Contohnya lah. Okay, so the slow step in the mechanism is called the rate determining step. Okay, even though dia slow tapi dia penentu whether the reaction proceed slower ataupun faster. Dia penentu tau, dia penentu whether the whole reaction tu cepat atau lambat. Okay, right. So the rate law for the rate determining step is directly related to the rate law for the overall reaction. Since dia penentu, that means we can say that it is directly related to the rate law for the overall reaction. Sebab dia penentu kan? So dia directly related to the rate law for the overall reaction. Okay, alright. So this is another example. Okay, kata kalau you nak pergi office, you kena sampai pukul 7.30 AM. You must be there at your office by 7:30 AM. So later than this, that means you are late. Okay, so you pun tahu perjalanan, the journey from your home to your office. Okay, dekat mana yang you selalunya akan stuck. Okay, so Plaza A. Katakanlah you bertolak pukul 7. You expect nak sampai 7.30. Lepas tu you ada masalah macam ni, rate determining step ni. Plaza A adalah untuk case number 1. Okay, case number 1, Plaza A is the rate determining step. Walaupun Plaza B, Plaza C, Plaza D later on, perfect. Okay, flow okay je. Nicely flow. Okay, tak ada masalah jam ke apa. Tapi because of this one part here, everything will be slow down lah. Okay, everything will be slow down. The rate will be, even though B ni perfect, okay. Tapi A ni slow, the rest will be slow. You akan tetap lambat sampai for your work. Okay? Ini kalau case slow dekat Plaza A, case slow dekat Plaza B. Okay, alright. So that is all for now. Okay, the rest we will continue during our 5 to 6 lecture lah. Okay, alright. So saya pun dah terlarat ni, nak kena baring kejap, berehat. Okay, alright. So if you do you have any questions so far related to this rate determining step, guys?
Oh, madam.
No, Right. Okay. Alright. So if there is no question, I think that is all for now. Okay. Thank you, everyone. So see you at 5. Okay. Okay. Bye bye. Okay. You may leave the session.
See you later, madam.
Okay. See
Thank you,
you.
madam.